With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us try to solve the given problem. So the given problem simply state a metallic rod of length 1 meter has one end free and the other end rigidly clamped. Longitudinal stationary waves are set up in the rod in such a way that there are total 6 antinodes present along the rod. Now the amplitude of the antinode is simply 4 into 10 raised to the power minus 6. The Young's modulus and the density of rod is 6.4 into 10 raised to the power 10 Newton per meter square and the density is 4000 kg per meter cube. Consider the free end to be at the origin and t is equals to 0. The particle at the free end are at positive extremes. Now what we have to find? We have to find the magnitude of strain at the midpoint of the rod at t equals to 1. So for better understanding of this question, let us try to draw a diagram. So you can see here, this is our rod, right? Now what will happen is that stationary wave will simply set up in this rod. How the stationary waves will simply set up? This is the clamped end and this is the free end. Now here a wave will travel, incident wave will travel from here to here, and then we will have a reflected wave, and due to the superposition of incident and reflected wave we will have a stationary wave like this. Now there are total 6 antinodes, it is mentioned in the question, right? And the origin is simply here. We are taking x is equals to 0 at this point, right? So this is the 6th antinode and this is the first antinode. Now if we want to write the equation of the stationary wave which is formed in this rod, that will be simply given by y equals, we have been given some parameter, and if we use that parameters, so we can write 4 into 10 raised to the power minus 6 cos 11 pi. This will be cos 11 pi by 2x into cos 22 pi into 10 raised to the power 3t. Now this is the equation of the stationary wave which will be set up in this. Now if you want to find out the strain, equation of strain produced in this rod, so what you have to do, you have to simply, for strain, to find strain at any point, what you have to do is that you can see that the particle at all the points on this rod will be simply oscillating, and if you want to find out the strain, so what you have to find, you have to find dy divided by dx. So you have to differentiate this equation, then you will get the value of strain, equation of strain along this length of the wire. So how can you get the value of strain or the equation of strain? If you differentiate this with respect to x, this will be 4 into 10 raised to the power minus 6. This will be treated as constant, so this will be simply nothing but cos 22 pi into 10 raised to the power 3t, and when you differentiate this, this will be simply minus sine 11 pi x divided by 2. Now you can also write it like this. So strain, you can also write this like this, and there will be simply, this is 11 pi divided by 2, because when you differentiate this again, what you are going to get is 11 pi by 2. So let us simplify this further. So we can write this 4 into 11 pi divided by 2 into 10 raised to the power minus 6, and this is cos 22 pi into 10 raised to the power 3t into this, we can write it like this, this will be simply sine pi plus 11 pi x divided by 2. Now this minus sign will be simply compensated here. Now this is the equation of strain that we have found out. Now what else do we need to find out? We have to find out the magnitude of strain at the midpoint of the rod at t equals to 1 second. So we have to place the value of t equals to 1 second, and we have to write x equals to, now at the midpoint of the rod, simply x is simply equals to 1 upon 2. So let us try to put the values here. So what you are going to get is a strain at the midpoint strain at midpoint will be simply, this is 2 into 11 pi into 10 raised to the power minus 6. Now when you put t here, this will be cos 22 pi into 10 raised to the power 3, t is simply 1, into this will be sine. When you put the value of x equals to 1 upon 2, so this is nothing but it is equals to sine pi plus 11 pi by 4, right? So you can see that this is simply a multiple of pi, 22,000. This will be simply 22,000 pi, the argument here. So this will be simply an even number, so this will be 1. So you can write the strain at the midpoint will be, this is nothing but 2 into 11 pi into 10 raised to the power minus 6 into 1, and this will be simply nothing but this will be, now this will be here, what we will have is, this will be sine pi plus pi by 4 is simply nothing but it will be minus sine 11 pi by 4. And now when you put the value, what you are going to get is, you are going to get 11 root 2. If you put the value of this, you are going to get 11 root 2 into 10 raised to the power minus 6. Now there will be a pi also. So this will be the final answer. I hope you understood the entire explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.